Now let's take a look at true trinomial. Trinomial expansion, a plus b plus 3, c, we got 3 terms here, and this raised to the first power, it didn't even bother showing. So it's equal to that, obviously. But when you FOIL this trinomial, you get this. But I would want you to get some sense of the coefficients. For the square terms, you get 1, 1, 1. Others have 2, 2, 2. Okay, so far so good. What if it was raised to the third power? The cube terms have 1, 1, and 1. And the other terms have, some of them have 3. Most of them have 3. But others, one has 6. One that has all 3 terms have 6. Now, what if it's raised to the fourth power? Of course, the fourth power ones are all 1s, 1, 1. Okay. But others have different coefficients like 4, 6, 12, 12, 12, and so on. What if it's fifth power? Then you get very different coefficients. We get 1. And for the fifth one, it will be fifth power. Where did it go? 1. Coefficient is 1. For the fifth power ones, if I could spot them. Here. They are. Others have, this kind of sounds familiar. 5 and 10 and 20 and 30 and those things. But can you get some pattern out of this? Can you understand how these things work? And also there's another very important thing you got to notice here. That is how many terms there are. Oftentimes that's the only thing they are asking for. When you raise to the first power, obviously you will have 3 terms. This number of terms is actually number of possibilities. So in other words, if you have 3 colored books, you got a red book, green book, and blue book, how many ways can you pick one? 1. There are 3 ways. What if you have a red book, green book, blue book? How many ways can you have unlimited supply of them? How many ways can you take 2? 1, 2, 3, 4, 5, 6. There are 6 ways to take them. 6 ways or 6 terms. What if you had 3? You're taking 3 books out of these 3 different books. How many ways can you do that? Well, the answer is 10. You can count them. So can I, and we did, is 10. What if you're taking 4? Suppose there is 3 different flavors of candy in the candy store. You're supposed to take 4 of them. How many ways can you take them? The answer is, if you count them, it's 15. The next one is going to be 21. Can you see some pattern in this? So we are dealing with 2 things here. What kind of coefficients we get? The coefficient will be important if we ever have questions like, what's the chance that you took 2 books out of unlimited supply of 3 different types, 3 different colors. There are 3 different tiles, red tile, blue tile, and green tiles. And then you took 3 tiles out of it. What's the probability that you took 1 blue and 1 green, for example? That would be 2 out of 6, for example. That's how you do this. But the thing is, do you have to memorize these numbers? Is there some elegant Pascal's triangle that you can use to just reproduce these numbers on the fly as you need it?